Okay, we are going to talk about sequences today. And when you say sequences, that is if like we had an XY data table and we had some terms here, 1, 2, 3, and 4. And then numbers down here, 2, 4, 8, 16. So this is what we call a sequence. And I would be able to tell you what the next terms were by simply finding the pattern and then telling you the next term. So if I wanted to find the fifth term, I would figure out what the rate is. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So I would simply go here and multiply by 2 to get 32. So that fifth term then would be 32. So I used a rate of 2 to find that. But what if I asked you to find the 15th term? I want to know what the 15th term is now. That is going to be a little tougher to do because I would have to go 6, 7, 8, 9, 10, 11, 12, 13, and 14 to find that 15th term, which is going to take a lot of time. So there is an easier way. Since this is being multiplied, go back here. This is being multiplied, we can use what we call a geometric explicit function or equation. Geometric right here simply means that it's being multiplied. So if the pattern is not being multiplied, we cannot use geometric. Geometric is only for multiplication whenever that common rate and or difference is being multiplied. So what we can do here is use our geometric sequence. And a geometric sequence, we are going to see a few different variables than what we're used to. So if I want to find the 15th term up here, I would use this geometric explicit function. And it written out algebraically is a sub n equals a sub 1 times the rate n minus 1. Now these right here, these a's and the n's, these all mean different things, so that this a means term. N is the term you want to know. R is the rate. And then this N simply means, again, the term you want to know. And A of 1 tells me this is the first term. So A sub 1 means first term. So now that we have this equation, all we have to do is plug in the numbers that we do know. I do know the first term, I do know the rate, and I know the term that I want to know. So up here, I'm going to go back and look at my table. A sub n tells me I want to know the 15th term, so I'm going to just plug everything in here that I want to know. Ace I do not know because I don't know what the 15th term is. I want to know the 15th. The first term, a sub 1, is the first term, which would be right here, 1, so it'd be a 2. R is the rate, so the rate is 2. And then n minus 1, I want to know the 15th, subtract 1 from that. Now it is just simply a matter of me solving this equation. So 2 to the 14th power is what we're going to do there. is going to get kind of small, sorry. 2 to the 14th power, it's going to be 1, 6, 3, 8, 4. So this is what 2 to the 14th power is, because 15 minus 1 would be 14. So that is the power that I'm going to take that to. So now I just simply multiply it by 2 to finish this out. And my 15th term, so my ace of 15, is going to equal 3, 2, 7, 6, 8. Alright, this is a lot of writing up here. I was trying to cram it all in. So let's do a couple more examples just so that we know. So I'm going to rewrite the equation. Ace of n equals ace of 1 times r n minus 1. Okay, so if I had a sequence that was 1, 3, 9, 27, and I want to know the 8th term. So instead of multiplying out each time to find the 8th term, I am going to just plug my numbers into this equation. I know the first term, I can find the rate, and I know the term that I want to know. So I can just simply plug some numbers in here. What is the rate? What's happening here? I am multiplying these by 3 to get the next number. These are all being multiplied by 3. So what I'm going to do here is I'm going to plug some numbers in. The first term right here is going to be 1. I got that from my sequence over here, so that'd be 1. My rate is going to be 3. And then the term I want to know is the 8th term, so 8 minus 1. Now it is just a matter of solving. So I'm going to have 1. I'm going to simplify this a little bit to the 7th. And now I can solve. So 3 to the 7th power is 2,187. Multiply that by 1, and it is 2,187. So the 8th term for this sequence would be 2,187. Let's try another one. Ace of n equals ace of 1 times the rate, n minus 1. So if I had a sequence of 64, 16, 4, and 1. And I want to know the 6th term. Okay, so what I would first need to do is I'm going to find this rate. What is happening to 64 to get to 16? Well, I'm dividing by 4, or multiplying by 1/4, which is also 0.25. And then 16 to get to 4, I'm doing the same. 4 to get to 1, I am doing the same. So I know that this is my rate. I do not do division. We can never put a division in there. So I am going to use 1/4 or 0.25 for my rate. So the first term is going to be 64. My rate will be 0.25. And the term I want to know is the 6th term. So now I'm just going to take these numbers and I'm going to plug them in to my equation. So I've got the first term, which is 64, times the rate, which is 0.25, and the term I want to know, which is 6, and take away 1 from that. So now it's just about solving. I'm going to have 64 times 0.25 to the 5th power is 0.00098 to figure out what this is. So then 64 times 0.00098 is 0.0627. So this would be my sixth term for this sequence. And that is how you write an explicit geometric function for finding the nth term in a sequence.